Welcome back. This is Webwork 6.1, question 1. And here we want to determine the radius and interval of convergence for the series x to the power of n over n factorial. So we can apply the ratio test to the series. And the ratio test states for that a series a of n, if the limit at L limit as n approaches infinity over the absolute value over a sub n plus 1 over a sub n, it exists, and L less than 1, the series converges absolutely. If L is greater than 1, the series diverges. And if L is equal to 1, the test is inconclusive. So for our specific problem, our series, a of n is equal to x to the power of n over n factorial. And we need to find a, n plus 1, which is equal to x to the power of n plus 1 and n plus 1 factorial. Now we can apply the ratio test, taking the limit as so. And this simplifies to this times n factorial over n plus 1 factorial. Simplifying that further gives us x over n plus 1. And this is as far as we can go. And that's just using your power rules and your algebra, just from getting one step to the other. It's no calculus involved, just algebraic rules. Now, applying the limit as n approaches infinity, it just goes to 0 because it's in the denominator, and we know that by now. So this limit of n of infinity of x over n plus 1 is equal to 0. And because this limit is less than 1 for all x, the series converges for all x. Since the ratio test showed convergence for all real numbers x, the radius of convergence r is infinite. And then, which also means the interval of convergence is negative infinity to infinity. And that means, I believe, so that answers this. And from here, based on the results of above, we conclude that the series converges on the interval. Since our interval is negative infinity to infinity, it clearly is convergent on the interval. And that is our final solution to question 1.